Today we talked about sector area in class, and this is a lot like arc length from last class. So if you didn't see arc length, look back at the previous video, will also really help you. But if you missed arc length, basically all we did was we found the length of an arc of a circle, or a piece or fraction of the circumference. And how we did this was we did the circumference, 2 pi times radius, times the fraction we wanted. And this one would be 123 degrees out of 360 for that red arc length. Right? We don't want the whole thing. We want a fraction of it. So example that was really easy yesterday, right? If we did half the arc length, it would be 180 out of 360, which is just half of it. But it's hard when it's like a weird number like 123. So it's just 123 degrees, the part that we want, out of the whole circle, which is 360. So then we would just fill this in. This is 4, multiply it. Not going to go over that right now. So today we're going to do arc length, or sector area, my bad. And sector area is about the area of a circle, but we want a piece of the area. So when I think of this, I think of pizza, right? We don't want the whole pizza. We just want a slice or a fraction of it. But the same thing as arc length is going to happen. We're going to do this. To find the area of a sector, we do pi r squared, or the whole area, times the fraction that we want, the angle out of 360, the part of the circle out of the whole. So this is the big formula I want to write down. Area of a sector is angle out of 360 times pi r squared times the whole area. So instead of getting the whole area of the circle like pi r squared, we just want theta out of 360, the part out of the whole thing. So it's basically arc length. The only difference is we use area now instead of circumference there. So let me show you an example of how we would calculate the area of a sector. So if I wanted to calculate the area of the blue sector, right, I see, it's not the whole area. So my sector, I'm just going to put an S for sector, equals, well, I know the whole area is pi r squared, but I don't want the whole thing. So I'm going to multiply that by the central angle, the angle that I want out of 360, or the fraction of that circle. So for this one, I'm just going to fill in what I know. I don't know the sector, that's what I'm finding. Pi is just pi, 3.14. The radius is 10, so 10 squared, which is 100, times, and it's 115 out of 360. That's the fraction of the circle I want. So again, I could just plug this in my calculator. I'm just going to copy and paste it, make life easy, make your video quicker. Oops, typed it twice. There it is. So it's 100.35 or 36. 100.36. Let's just round it to the nearest tenths place. So that is 100.4 units squared. That's the area of this. Now the whole circle, right? If I did the whole circle, it would just be pi r squared, which is 100 times pi. So the whole circle is 314. 314 units squared. And this blue piece is just 100 of it, right? And that makes sense, right? 100 is like a third of it. It looks like about a third of it. So mentally, I'm just checking my work. Now, if I wanted to find the area of the white sector, this second question, I got to think a little. What am I going to do here? Well, I don't know the central angle to the white piece, but I know it would add up to 360 with 115. So I'm going to do 360 minus 115. 245. So this central angle for the white piece is 245 degrees. So I'm going to do the exact same formula. The only difference, if I want to find the white piece, though, I'm not going to use 115. I'm going to use 245 because that's the central angle for the white piece, the rest of the circle. And if I type this in my calculator, it should add up to 320 with 100. So it's going to be about 2. It's going to be around 200. Let's see. Yeah, 213. So the whole thing was 314. This piece was about 100.